All right, geometry, still unit 6. We're working on lesson 13. The title is intersection points. So first, our warm-up is going to help us compare 4 graphs. Which one doesn't belong? And as I've told you, these are my favorite when we're in the classroom because there's no right answer or wrong answer. So what do you guys think? Which one doesn't belong? I mean, if I look at figure A, it's the only one with a vertical line. So maybe it doesn't belong. If I look at B, it's the only one with a horizontal line. So maybe it doesn't belong. C, only one with a parabola. So maybe parabola and a horizontal line. D, it's the only one where the line doesn't intersect. So maybe. All right, let's move on. Here, we're going to be talking about circles and lines today. We're going to solve a system of equations, linear and quadratic type equations with 2 variables. We're going to estimate the solutions on the graph and then verify that they are the solutions algebraically. All right, so we're going to estimate and then verify. So first of all, let's look at this equation. This equation, x minus 3 quantity squared plus y minus 2 quantity squared equals 25, represents a circle. Graph this circle on the coordinate grid. Always a challenge. Here, we know that the radius of this circle is 3, 2. Nope, the center is 3, 2. I'm sorry. And the radius is 5. It's the square root of 25. So let's plot 3, 2, and then try to do 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I never actually make a circle. 1, 2, 3, 4, 5. It's just too hard. That's terrible. That's a little bit better. So we have a circle. It's not a terrible circle. It's not an awesome circle. Graph the line y equals 6. So I'm going to do that in red. Y equals 6 is a horizontal line that crosses the y-axis at 6. At what points does this line appear to intersect the circle? I certainly can't tell with my hand-drawn drawing, but maybe it intersects at 1, sorry, that's highlighter. 1, 6 and possibly 6, 6. Maybe. So how can we verify that the 2 figures really intersect at these points? Carry out whatever procedure you decide. I am going to plug in those points to the circle equation and see if I get a true statement. So I'm going to have, so here we're on number 3. X, nope, I need to plug in 1 minus 3 squared plus, let's see, 6 minus 2 squared, and that's going to equal 25. So I'm testing this point first. 1 minus 3 is -2. Quantity squared is 4. 6 minus 2 is 4. Quantity squared is 16. That equals 20. So that doesn't work. All right, let's try another one. Actually, I looked at the answer key. I knew one of mine wouldn't work because my drawing is so bad. All right, so we're doing -3 squared plus -2 squared equals 25. So let's plug in 6 and 6. So 6 minus 3 is 3 squared. 6 minus 2 is 4 squared. 25. So I have 9 plus 16 is in fact, ooh, that should be 25, sorry. My mind got ahead of me. So when it's a true statement, that means that it does work. So 6 comma 6 is on the circle, and 1 comma 6 is not. The other answer is actually 0 comma 6. But my drawing was so bad that we really don't know. All right, graph the line y equals x minus 2. At what points does this line appear to intersect the circle? So hold on. All right, I just copied the circle from the last slide because it got a little messy. So question number 4 says, graph the line y equals x minus 2. At what points does the line appear to intersect with the circle? So here I have a y-intercept of -2 and a slope of +1. Let's see if I can, oops. I tried to turn my screen, it flipped everything. That was bad. All right, where does it seem to intersect? Somewhere there and there. So I'm going to guess that is approximately, I'm assuming that circle is really bad. So we're going to say that is 0 comma -2 and 6 comma 6. If I would have kept that, sorry, 6 comma 5. Yeah, 7 comma 5, I'm sorry. 7 comma 5. So we're going to test this again, right? Our equation for a circle is x minus, I have to look it up, x minus 3 squared plus y minus 2 squared equals 25. So let's test 0 comma -2 first. So our x term is 0 and -2. So I get -3 squared plus -4 squared. 9 plus 16 is 25. So that one does work. And how about 7 comma 5? So I'm writing down the equation of a circle again. Let's try this one. X is 7, y is 5. 7 minus 3 is 4 squared. 5 minus 2 is 3 squared. I get 16 plus 9, and that does equal 25. Cool, so those 2 points worked, even though it didn't look like one of those dots was on the circle. I guessed that it probably was because my drawing was so bad. But I verified it with algebra, and we're good. For some of you that may want a little extra added information, I could also verify that that point is 5 units away from the center of the circle using the Pythagorean theorem. So that is 3 units. 1, 2, that is 4 units. And if I do Pythagorean theorem, 3 squared plus 4 squared is 5 squared. Okay, so I could also do it that way. And I can do that with both points. Okay, 3 squared plus 4 squared is 5 squared. Cool. So another idea, I just used the equation that was given to us. Both work. All right, so the next section is called creating lines. We are going to combine concepts of parallel and perpendicular lines and circles and consider possible intersections of circles and lines. Okay, that's what we're doing in this section. So first of all, let's write an equation representing the circle in the graph. How do we know where the center of the circle is? How do we know what the radius is? Well, if I just sort of look here, let me get my highlighter out. I draw a line there and there. It looks like my diameter is 20 units that direction, 20 units that direction. So half and half is 10. that is the middle of the circle. Let me erase all that. Oh, I can't erase the highlighter. Hold on. So I know the center is 0, 0. And the radius is 10. So if I write an equation there, I'm going to have x minus 0 squared plus y minus 0 squared equals 10 squared. All right, I can write 100 there if I felt like it. That works fine too. So write and graph equations for each line described. A, any parallel line to the x-axis that intersects the circle at 2 points. I need it parallel to the x-axis. That means it's going to look like that or like this, anywhere up and down the y-axis. If I make any line horizontal, it's going to be parallel to the x-axis. So part A, I could say anything. Y equals any number as long as that number is between -10 and 10. All right, I can put any number from that range into y equals. Y equals 8 is right here. I could say y equals -2. Any number between -10 and 10 will intersect that circle at 2 points. 1, 2, 1, 2. How about part B? Any line perpendicular to the x-axis that doesn't intersect the circle. So perpendicular to the x-axis means that it's outside of the circle. So that would be any x's bigger than 10 or any x's smaller than -10 will give me that answer. Okay, and that's a line, like I could say x equals 11, and that's an answer. Or x equals -10.1, and that's an answer. All right, how about C? A line perpendicular to y equals -1/3 x plus 5 that intersects the circle at 6, 8. So perpendicular to this line means for this line, my slope is -1/3. So I want my perpendicular slope to be, I've been doing that different. My perpendicular slope to be the opposite sign, which is positive, and the reciprocal fraction. So I can say y, I'm going to use this ordered pair right here, y minus 8 equals 3 times x minus 6, and that would be my equation. Okay, in the point slope form. Did I graph it? I did not graph this one, so let's do that. I'm going to put a dot at 6, 8. 6, 8. I don't know if I'm going to be able to erase that. Oh, I can. I just need that space. So 6, 8 is right there. And the slope of 3. So 1, 2, 3, 1. 1, 2, 3, 1. Now at this point, I'm looking at number 3, and I need to graph this line all the way and then find where it intersects the circle on the other side. So I actually, rather than drawing it by hand, I'm going to use the slope. I'm going to keep on counting, like down 3, 1, 2, 3, 1. Oops, 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. All right, that's going to be way more accurate. Let me turn back to yellow. Than me trying to guess where that point is. All right, so it is crossing the bottom at 0, -10. And that makes sense, because if I use Pythagorean theorem here, there's really no triangle to draw, because the distance there is 10 units, which is the radius. So Pythagorean theorem was a silly idea of mine. But yeah, it's just a distance of 10, which is the radius. That was actually it for today. Sorry, I thought there was one more slide. I miscounted. All right, so good work.